everyone, this is Babitha, working as Assistant Professor in the Department of ECU in Institute of Aeronautical Engineering. In this session, I'm going to discuss about operational amplifier. So while coming to the contents, I'll revise what is meant by amplifier as well as differential amplifier circuits before going to the operational amplifier. Why? Because why we are switching from the amplifier to operational amplifier. And next, we're going to see the ideal characteristics of operational amplifier and also the equivalent circuit of the operational amplifier. So here, before going to the operational amplifier, why we came to this operational amplifier, even though we are having the single stage amplifiers as well as multi-stage amplifiers and also the differential amplifiers. So in the case of normal amplifier circuit, when we provide the input signal, amplified signal we will get across the output of the amplifier. So this particular single stage amplifier will provide certain amount of voltage gain, current gain, and the required input impedance as well as output impedance for the devices. So whatever the parameters which are providing from this single stage amplifiers, those are not sufficient in order to run some practical applications. So in order to overcome this, next we went for the multi-stage amplifiers. So in the case of multi-stage amplifiers, we are cascading more number of or two or more number of single stage amplifiers here, so that we can able to improve the voltage gain as well as current gain and also the input output impedances required for our applications. So because of cascading different types of configurations of the amplifiers, we can able to achieve different parameter improvement. In some cases, we may improve the voltage gain. In some cases, we may improve the current gain. In some cases, we may improve the input and output impedances. So depends upon our requirement, we can choose any one of the multi-stage amplifiers here. So these multi-stage amplifiers, by cascading same type of amplifiers, we can achieve, or else we can cascade different type of configured amplifiers also, so that we can able to improve any one of the parameter, so that we can utilize for our practical applications. So next we went for the multi-stage amplifiers, and after that we also discussed about the differential amplifier. So though the single stage amplifiers as well as multi-stage amplifiers are providing the required parameters in order to run the practical applications, still also we are moving for the differential amplifier. So what is the basic difference between this normal amplifier as well as this differential amplifier here means? In the case of a single stage amplifier, we are providing the single signal, that may be the voltage or current, to the amplifier, so that it will amplify that particular applied signal. And in some cases, the single stage amplifiers are restricted to low frequency signals only. That is nothing but those can able to amplify the low frequency signals only. In the case of multi-stage amplifiers also, those are restricted to some mid-frequency range of signals only. That is nothing but they may provide a proper voltage as well as current gain for the mid-frequency range of signals. Those are not providing the proper amplification in the low frequency as well as high frequency range of signals. But in the case of differential amplifier, somewhat we can able to rectify that particular low frequency and high frequency problem. So in the case of differential amplifier, we can able to construct this differential amplifier by using two similar stages of the amplifiers. That is nothing but those are having identical characteristics. Those two stages of amplifiers are having similar characteristics. That is nothing but collector resistance of both the transistors are same, and the emitter resistances of both the transistors are same, and the biasing conditions of both the transistors are also same. So in such a way, we have to take two transistors and we have to interconnect the two transistors with a common supply, so that we can able to form the differential amplifier. So what is the basic function of this differential amplifier? So it will amplify whatever the input signals we are providing for the two stages of the amplifiers are the two transistors that will take the difference of the two applied input signals and it will amplify the difference of the two signals here. So that is the basic function of the differential amplifier. So these differential amplifiers again available in 4 modes that we discussed in the previous session. That is dual input balanced output differential amplifier and dual input unbalanced output differential amplifier, single input balanced output differential amplifier and single input unbalanced output differential amplifier. So in all the cases, in all the 4 types of differential amplifiers, so depends upon how many number of inputs we are taking, either 1 or 2, we can call it as dual input or single input. And while taking the output, where we are taking, whether we are taking the output across the common terminal of 2 collectors of the transistors, so that we can call it as the balanced output. Or else, if we take the output across any one of the collector terminal of the transistor, so that we can call it as the unbalanced output. So in each and every cases of this differential amplifiers, we can able to improve the gain parameters as well as input-output impedances. Or else, if we interconnect these differential amplifiers to make it as the multi-stage amplifier, we can able to improve the voltage gain in very much high extent. So that is the basic very advantage of the differential amplifier that may be in any mode. See, in the case of analysis of any type of differential amplifier, analysis is same here. The thing is how many number of inputs we are applying and at what condition we are measuring the output. That is the only difference, but the analysis part is similar for all the 4 types of differential amplifiers. And from the differential amplifiers, we can able to get the high current gain as well as high voltage gain, so that we can able to run different types of high frequency applications by using differential amplifiers. So even though we are having all these single stage amplifiers and multi-stage amplifiers as well as differential amplifiers, then why we are moving for this operational amplifier? See, the name itself indicating it is the amplifier so that it will perform the amplification. But what is mean by this operational here? So operational means it is going to perform all the mathematical operations here. That is nothing but it can able to perform the addition, subtraction, multiplication and also integration and differentiation. So this particular operational amplifier is performing some mathematical operation. So that's why it is named as operational amplifier. So it is performing this particular mathematical operations as well as it is amplifying the applied signal. It is performing both the functions. So that's why it is named as operational amplifier. So along with this particular mathematical operations, operational amplifier can also use it to generate different types of signals, that may be the sinusoidal signals or non-sinusoidal signals. So it can also useful to generate the signals also. See, in the case of normal single stage amplifiers or else multi-stage amplifiers or else in the differential amplifiers, we can able to perform the amplification and we can able to improve the parameters of the amplifier, but we cannot able to perform any kind of these operations by using normal amplifiers. But in the case of operational amplifier, we can able to perform all these operations along with the amplification function. So that is the basic difference between the normal remaining all the amplifiers and this operational amplifier. So while coming to this operational amplifier, it was invented in the 1948. So first operational amplifier is in this form. In this way it is there, and after that it is designed with the vacuum tubes here. After that it is designed with the vacuum tubes here. So and after technology improvement, again The new version of operational amplifier is invented in the 1963 in the form of IC, that is integrated circuit. So here IC is nothing but integrated circuit. Why it is called as integrated circuit means it can able to interconnect so many number of components within the single chip, so that we can call it as the integrated circuit. Nowadays, operational amplifier is available in the form of three different types of integrated circuits. In that, first one is 8-pin dual-in line package, that is 741 operational amplifier. So this is the 741 operational amplifier. And second type of operational amplifier is the TO58 metal can package, that is this one. And next, 8-pin small outline integrated circuit, so that is this one. So this operational amplifier is available in three different packages, that is tip package or SOIC package or metal can package. In all the cases, we will be having 8 pins here. And why this 741 operational amplifier call it as 741? Here 741 is nothing but this particular IC consists of 7 functional pins. 7 functional pins. So among that 7 functional pins, 4 are utilizing to take the inputs, that is nothing but 2 inputs. In the case of operational amplifier, internally we are having the differential amplifier. So in the case of differential amplifier, we are providing the 2 inputs for the 2 transistors. So that's why in the operational amplifier also we are utilizing the differential amplifier. So that's why it is having 2 inputs. One is the inverting input and one more is the non-inverting input. So among these 4 pins, 2 are the inverting input and non-inverting inputs, and along with this it will also take supply voltages plus VCC and minus VE are the supply voltages. Those also we are considering it as the inputs. So that's why 2 input signals and 2 supply voltages. So these 4 pins are meant for these 4 inputs, and the last one is for seeing the output, how much amount of output it is providing. Actually, total it is having 8 pins, but in that it is going to utilize only 7 pins. One last pin or 8th pin is unused pin here or not connected pin here. We are not using for any purpose or any function in the 741 IC. Okay. So I have already mentioned in the olden days, operational amplifiers are designed with the vacuum tubes. So if we design the operational amplifier with the vacuum tubes, we are having some disadvantages. Here the size of the vacuum tubes are very high, so the operational amplifier is very bulky if we design with the vacuum tubes. And the power consumption is also very high if we design with the vacuum tubes, and the cost of this one also very expensive if we design with the vacuum tube. So in order to overcome that only, nowadays we are getting in the form of small chips, that is in IC. Okay. So 741 operational amplifier is consist of, it is a general purpose operational amplifier. So it is first manufactured by the Fairchild Semiconductors in the 1963 year. That is the first invention of the 741 integrated circuit operational amplifier. And I have already mentioned in the number 741 indicates 7 functional pins, 4 pins capable of taking the inputs, and 1 is to provide the output here. And so what is the basic advantage or function of the 741 operational amplifier? Means it can able to provide the high voltage gain, and it can be operated over a wide range of voltages. That is nothing but it can be applicable for any kind of frequency signals from low frequency to very high frequency range. So this operational amplifier can able to amplify the all frequency range of signals. In the case of normal amplifiers or single stage amplifiers, those are restricted to low frequency signals. And in the multi-stage amplifiers, those are restricted to mid-frequency range of signals. In the case of differential amplifiers as well as in the operational amplifiers, those can able to amplify the all frequency range of signals. So here, if you wanted to know the operational amplifier, it is the DC coupled high gain electronic voltage amplifier here. So why we are calling it as a high gain electronic voltage amplifier means it can able to provide the very high voltage gain. That is the main advantage of the operational amplifier. So that's why we are moving for this operational amplifier. And it is having two inputs. So the two inputs we are taking it as the differential inputs, and it is having single output. That is nothing but overall two inputs it will take, and it will provide the single output here. So this operational amplifier is an integrated circuit. So it can operate as a voltage amplifier here. So it is having the differential input, and that differential inputs are having opposite polarity. That is nothing but one input is positive input and the second one is the negative input always. And the output is the single output, and it is having very high gain. That means that the output signal is much higher than the applied input signal. So that's why we are calling it as the high gain amplifier. Okay, what is the basic application of this operational amplifier? Here it is. This operational amplifier can able to amplify both the AC as well as DC signals here. That is also one of the major advantage of the operational amplifier. And these AC signals are originally designed for computing, such as mathematical functions such as addition, subtraction, multiplication as well as integration. So it can able to amplify DC as well as AC signals, and it can able to perform all the mathematical operations. So this name operational amplifier came from its original user for these mathematical operations. So that's why it is abbreviated as op-amp. In short, always we will call it as op-amp. So if we add some external feedback components to this operational amplifier, so that we can utilize for many more different applications such as AC and DC signal amplification, and for the filtering applications, and for the oscillator, that is in order to generate the waveforms, and we can design the comparators, regulators and many more type of circuits if we provide the external feedback from the output to the inverting terminal or to the non-inverting terminal. If we provide the external feedback, so that we can able to design different types of applications. So this operational amplifier is having the linear applications as well as non-linear applications. In the linear application means it will act like a voltage follower, integrator, differentiator, etc. In the non-linear case, it can able to generate the waveforms. It acts like an oscillator. So now we'll see the block diagram of this operational amplifier. So in this internal circuit or else block diagram of operational amplifier consists of 4 stages. That first one is the input stage. In the input stage of operational amplifier, we are going to utilize the differential amplifier. So which kind of differential amplifier we are using here? It is dual input balanced output differential amplifier. That is nothing but dual input means it is having 2 inputs. One is the positive input and one is the negative inputs. So the positive input we are calling it as the non-inverting input, and the negative input we are calling it as the inverting input of the differential amplifier. So that 2 inputs of the differential amplifier only acts like a input terminals of the operational amplifier. So balanced output means across 2 collectors of the differential amplifier, we will measure the output. So that's why we will get the output here, 2 outputs here. And after that, the output of this DIBO, dual input balanced output differential amplifier, is again connected to the intermediate stage. So in the intermediate stage, we are going to use a dual input unbalanced output differential amplifier. Why we are using this dual input unbalanced output differential amplifier means here in the operational amplifier we require two inputs but the single output. So to get that single output, we are using here it as the dual input unbalanced output differential amplifier. And next stage is the level shifting stage. In this case, we can utilize the emitter follower circuit using constant current source. So here we may get some two different levels of output voltages. In order to make it a single level or single voltage, we are using this level shifting stage. And after that, we are utilizing the output stage in order to measure the output signal, how much we are getting from the operational amplifier. So in the case of output stage, we can utilize complementary symmetry push-pull amplifier in order to provide the different angle signal here. See, the output of the differential amplifier is depends upon how much amount of input signals we are providing here. Suppose our positive input, that is non-inverting voltage, is high compared to this one. If we take it as V1 and this one is V2, means suppose if V1 is greater than V2, means the positive value is greater than the negative value, so that the output is in positive form now. Or else, if my V1 is less than V2, that is nothing but negative value only higher than the positive apply voltage. So in that case, my output, I will get it as negative value. So depends upon the applied input voltages, we will get the positive or negative output in the case of operational amplifier. So in order to make that particular difference, we are utilizing the complementary symmetry push-pull amplifier. And about this each and every stage of operational amplifier, we will see in the later slides. But before going to that, why we are using this particular differential amplifier in the different stages of operational amplifier. So this is the symbol of the operational amplifier. So this is the 741 operational amplifier. So for this, we are connecting two inputs, that is the inverting input, non-inverting input. So this is the second pin and this is the third pin. And the positive power supply we will connect it to the seventh pin. And the negative power supply we will connect to the fourth pin. And the output we will measure across the sixth pin. Okay, so these are the signals to provide the input and to take the output, and this is the basic symbol we will utilize for the operational amplifier. So in the case of input stage of the operational amplifier, we are using the dual input balanced output differential amplifier. So the speciality of this DIBO is it will provide the differential gain as well as the common mode gain. So what is meant by this differential gain as well as common mode gain? We will see. So in the case of differential amplifier, we are using the two inputs V1 as well as V2. Okay, and how we are applying this particular two input signals to the differential amplifier means, base of the first transistor we will provide the V1, and for the base of the second transistor we will provide the second voltage V2. So the differential voltage VD is nothing but V1 minus V2 always in the case of differential amplifier. So it is going to, even though we are providing the two input signals across the two bases of the transistor, it will amplify the difference of that applied two input signals. So that difference we are taking here it as the VD, that is the differential voltage. So how much output voltage we can expect from this differential amplifier is V0 into AD into VD, where AD is nothing but the differential gain. Okay, differential gain. So AD is equal to V0 by VD. Suppose if I apply both the input voltages are same, V1 is equal to V2. So in that case, what will get VD value? We will get it as 0. So in that case, how much differential gain I will get? V0 by 0 is nothing but infinity. So in the ideal operational amplifier, the differential gain is infinity. Okay. Why we are getting it as infinity means when we are providing both the inputs are same voltages. So in the case of common mode gain, what is meant by this common mode? So two inputs we are taking V1 and V2. The output voltage in terms of common mode gain is AC into VC, common mode voltage. So in the common mode voltage means we will take the average of the two applied input signals as the common voltage. So the common mode gain is V0 by VC. So in this case, if we provide the common voltage, almost we will get V0 value as very less. So AC value we will be getting here as 0. So in the ideal operational amplifier, the common mode gain is 0. So these two values are in the in the ideal case. So in the ideal case, the differential gain is infinity and the common mode gain is 0. But in the practical case, operational amplifiers, if we see the differential gain, we will get it as large value and the common mode gain, we will get it as very small value. Why? Because in any cases we may not reach the ideal characteristics. In the practical case, because of any component variations or due to the temperature variations or due to the parameter variations, we may not get the original ideal characteristics. So that's why in the practical amplifiers, we will get it as differential gain as large and the common mode gain as small. So overallly, in the practical operational amplifier, if we write the output voltage, that is the sum of differential voltage gain into differential voltage plus common mode gain into common mode voltage. So if we take any practical operational amplifier, the output voltage is sum of these two voltages. So in the case of operational amplifier, why we are getting in such a way means, in the case of differential amplifier, we are getting in this way. So this differential amplifier only we are going to utilize in the input stage of the operational amplifier. So that's why in the operational amplifier also we may get this amount of output voltage. And the third parameter from the differential amplifier is the common mode rejection ratio. So what is meant by this common mode rejection ratio? So the ability of the differential amplifier to reject a common mode signal is expressed by a ratio of common mode rejection ratio denoted by CMRR. That is nothing but AD by AC. Common mode rejection ratio is the ratio of differential gain to the common mode gain. So we will represent with rho, here it is. So if you want to express in terms of log, that is 20 log CMRR is equal to 20 log AD by AC in decibels. Okay. So this is the CMRR we will get in the differential amplifier. In the case of differential amplifier, we will get the highest CMRR, so that in the case of operational amplifier also we will get high CMRR in the case of practical amplifiers. In the ideal case, we may get it as infinity, but in the practical case, we will get it as large value. And what are the basic features of this differential amplifier and why we are utilizing the input stage of the operational amplifier? So the first basic feature is it will provide the very high differential voltage gain and low common mode gain, and it provides a common mode rejection ratio is very high, and it is utilizing two input terminals so that it can able to provide the very high input impedance, and the bandwidth provided from this differential amplifier is also very high, and it is having low offset voltages and currents. That is nothing but what is mean by offset voltage and offset current here. So whenever both the input voltages are zero in the case of a differential amplifier, practically we should not get, in the ideal case, we will not get any output voltage. If we are not providing any input for the differential amplifier, in the ideal case, it should provide the zero. But in the practical case, even though both the voltages are zero, we are getting some value here. So that value we are calling it as the offset voltage or offset current. That is nothing but whenever the input is in offset, also it is providing the output voltage and current. But that value is not required in order to run the practical applications. And it will provide the low output impedance. So now we will see the each and every stage of the operational amplifier. The input stage is the dual input balanced output differential amplifier. Okay. So this stage takes the input from both the input terminals, that is from the inverting terminal as well as the non-inverting terminal. So this is the input stage. Inverting input and non-inverting input. This is dual input balanced output differential amplifier. So it will take the inputs from the two input terminals, and the difference of the two input terminals it will take, and it will performs the amplification, and it will generate the two outputs here. That is the basic function of the input stage in the operational amplifier. Okay. So this input stage is having two inputs as well as two outputs. So it is a dual output differential amplifier or else balanced differential amplifier. So this stage accepts the inputs from source and give both the generated outputs to the next stage, that is the intermediate stage here. Okay. So this constant current source has excellent common mode rejection capabilities. Just now we have discussed the common mode rejection ratio in the case of differential amplifier. So that is also applicable for the operational amplifier. Why? Because the differential amplifier only we are using in the input stage, so that it is providing the very high common mode rejection ratio. And the next stage is the intermediate stage. So in the case of intermediate stage, so the output from the input stage is applied to the intermediate stage as the input, and it will provide the output here. So this is a dual input unbalanced output differential amplifier. Okay. So this stage is used to improve the overall gain of the operational amplifier. Here, instead of using the single stage, we can use the multiple cascaded stages in order to improve the high gain. So the input stage alone cannot provide the high gain. So because of that reason, we are adding the intermediate stage in the form of more number of differential amplifiers. So the basic function of this intermediate stages provide the very high voltage gain or the voltage gain required for the applications. And practically this intermediate stage is not a single amplifier, it is the cascade connection of multiple number of differential amplifiers. And the next one is the level shifting stage. So in the input stage, the differential amplifier is providing the two outputs from the ground level. So therefore, both the outputs are unable to serve the actual output terminal of the operational amplifier. Why? Because we require only single output, but it is providing two outputs. So by using this level shifting block, we can able to ground one of the output here. So this level shifting stage is used to shift one of the output terminal to the ground level, so which will serve the actual output of the operational amplifier. So the output of the level shifter block is given to the output stage of the operational amplifier. That is the last stage in the block diagram of the operational amplifier. So this output stage will accept the signal from the intermediate stage and it generates the final output of the operational amplifier. So as this stage amplifier has one input and one output, we can say this differential amplifier used in this stage is the single input, single output differential amplifier. So this, why we are using this particular single input, single output differential amplifier means in order to improve the power level of the operational amplifier. So because of providing the cascade connection of differential amplifiers, we can able to improve the voltage gain, and along with that we have to improve the power levels also. Because of that reason we are using this single input single output differential amplifier in the last stage of the operational amplifier. So the main intention of designing this output stage is to provide the low output impedance for the operational amplifier. So for any amplifier, the basic requirement would be input impedance should be very high and the output impedance should be very low in order to get the amplified signal. And one more advantage of this output stage is it will provide the very high peak to peak output signal. So the positive peak is plus VCC here and the negative peak is minus VE in the output stage of the operational amplifier. So till now we have seen the block diagram as well as different blocks in the operational amplifier and what is the basic function of that particular different blocks in the operational amplifier. So now we will see the ideal characteristics of this operational amplifier. So these are the ideal characteristics of the operational amplifier. In the ideal case, it can able to provide infinite voltage gain and it will provide the infinite input impedance so that it can able to run or drive any kind of signal source so that it cannot provide any loading on the preceding stage because of having infinite input impedance, and it is having zero output impedance so that it can able to drive infinite number of applications or devices here. And whenever the input signals V1 as well as V2 are 0 means the output is also 0 here. And it will provide the infinite bandwidth from 0 to infinity range of signals. That is nothing but it can able to amplify any range of frequency signal here without providing any attenuation. And it will provide the common mode rejection ratio is also infinite. And it will provide the infinite slew rate. So that is nothing but these are the ideal characteristics. So ideal operational amplifier can able to provide all these parameters, all are in the very high values. But in the practical case, we may not reach these values. So now we will see the equivalent circuit of the practical operational amplifier. So we have already seen the block diagram. In the case of block diagram of the operational amplifier, the input stage, from the input stage to the output stage, we have utilized the different types of differential amplifiers. Though any kind of differential amplifier we are utilizing here, but if we take any kind of differential amplifier, it is having two inputs and one output. So that's why in the case of operational amplifier also we are having two inputs and one output. So in the equivalent circuit also we are representing in that way. So in the input we require two voltages, so that's why we are indicating with the V1, V2, and the input impedance we are representing with the RA, and the differential voltage VD, that is the difference of V1 minus V2 we are indicating in the input side. So this particular section is the input side of the operational amplifier. So in the output side, it will provide the gain. That is nothing but voltage gain it is providing. The input voltage we are representing with the VD. So that's why gain also we are representing with the AVD here. And the output impedance we are indicating with the R0 here. So this is the output section of the operational amplifier. So in the equivalent circuit we have mentioned the input impedance, output impedance, as well as open loop voltage gain. Those we are representing it as Rin, R0 and AOL. AOL is nothing but the open loop voltage gain. This and all be represented in the equivalent circuit. And this particular operational amplifier can able to amplify the difference between the two input voltages. So that's why the output voltage V0 is the open loop gain times the differential voltage VD. So where VD is nothing but V1 minus V2. So that's why we replaced VD with the V1 minus V2. So where AOL is nothing but the large signal open loop voltage gain of the operational amplifier, and VD is nothing but the difference voltage of the two applied input signals V1 and V2. V1 is nothing but the non-inverting voltage with respect to ground. That is nothing but for the positive terminal of the operational amplifier we are providing the V1 voltage, and V2 is the inverting voltage with respect to ground. That is nothing but for the negative terminal of the operational amplifier we are providing the second voltage V2, and RA is the input resistance, R0 is the output resistance of the operational amplifier. So here this output voltage is directly proportional to the differential input voltage VD. So this operational amplifier will amplify the difference voltage. It cannot amplify the individual input voltages. Always it will take two voltages. Suppose we may give one of the input is 0, but overall it will take two voltages into consideration. And the polarity of this, the output signal polarity is decided by the polarity of this differential voltage VD. Suppose the voltage source AOL VD we are representing with the Thevenin's equivalent voltage. So R0 is the Thevenin equivalent resistance here. So this equivalent circuit will play the important role in analyzing the operational amplifier applications, and also it will provide the performance of the operational amplifier. So this is the equivalent circuit. So in the case of this operational amplifier, it can able to run the linear applications as well as non-linear applications. So in the case of linear applications, we will provide the feedback from the output to the inverting terminal of the operational amplifier. So by using this, we can able to design the voltage follower, adder, subtractor, integrator as well as differentiator here. So in the case of non-linear applications of the operational amplifier, we need to provide the positive feedback. That is nothing but we will provide the feedback from the output to the non-inverting terminal of the operational amplifier. So in that case, we can able to perform the logarithm operation and we can able to generate the different waveforms. That is nothing but it acts like an oscillator or schematic trigger circuit to generate the different types of waveforms. So oscillator means it can able to generate the signals without providing the any input signal. So we can able to design the design the oscillator circuit by using this operational amplifier without providing any external input voltage. So to make it as the waveform generator, we need to provide both the feedbacks at a time, positive as well as negative feedbacks. We need to provide at a time to generate the triangular wave generator. And to generate the square wave signal, we can utilize any one of the feedback signal here. So this and the applications of this operational amplifier we will discuss in the next session. So in this session we have discussed what is the requirement or what is the basic function of the operational amplifier and how we can able to construct the operational amplifier and what are the different stages function of the operational amplifier, and what are the ideal and practical characteristics of the operational amplifier, and also the equivalent circuit of the operational amplifier. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.